Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 7 from the Solomon L. Mechanics M1 paper, which corresponds to question number 12 from my end of topic worksheet from chapter 5, Forces and Friction. Now this question here is about inclined planes, and we're told that there's two golf balls P and Q being held at the top of planes inclined at 30 and 60 degrees to the vertical respectively. Both planes slope down to a common hole H, which is 3 meters vertically below P and Q. P is released from rest and travels down the line of greatest slope of the plane it is on, which is assumed to be smooth. So this is a smooth plane. Find the acceleration of P down the slope. So I'm just taking this section of the drawing which involves P. So this is a smooth plane, so therefore there's no friction. And this, as it moves down the plane, the forces acting on it will be simply its weight, which acts vertically downwards, and the reaction force of the plane on the object, because when an object is in contact, there is a reaction force between them, which doesn't really matter too much here because there's no friction. All right, so it's going to be accelerating down the plane in this direction. So we need to resolve the forces in that direction in which it is going. So I'm going to resolve the forces parallel as well as perpendicular to the plane. Okay, so this is the weight mg. That's the weight, and this is the component of the weight parallel to the plane and the component of the weight perpendicular to the plane. So what do I use for the angles? Well, I could use different things for the angles. Now here I could say that this is 30 degrees because they're corresponding to each other. Okay, in which case this would be mg times cosine 30 because it's going into the angle, and this component would be the mg sine 30. Okay, I could do that. Or I could say, if this is 30, then this must be 60 degrees. Okay, so therefore this is also 60 degrees here. Okay, if that's 30, that must be 60. We could work that out. So in this case, this would be mg times cosine 60, and this would be mg times sine 60. Okay, now I'm going to actually do it that second way because that's what we normally do. We're normally given this angle here, and we normally use that to work out what the angle is between the weight and the line of force of the reaction. Okay, so this angle is going to be 60 degrees. All right, if this is 30, this must be 60. And this angle here, we're going away from the angle, which is mg sine 60, which is the same as what we wrote before, mg cosine 30. The cosine of an angle is equal to the sine of 90 minus the angle. That's something that we should know from P2. And this component of the force this way, mg, this would be mg. Now you're going into the angle, so it'll be cosine 60, which is the same as what we wrote before, mg sine 30, because if it's 30 degrees, the cosine of 60 is equal to the sine of 30 for the same reason I just mentioned. Right, so if we resolve the forces parallel to the plane, okay, then we can see that the only force acting in this on this thing in parallel to the plane is mg sine 60. So we got mg sine 60, and that's the only force acting, so that's equal to the mass times acceleration, which is ma. Okay, we know that the resultant force is ma, F equals ma. So this is the resultant force, it's equal to the mass times acceleration. The masses will cancel out, so you're left with a equals g times the sine of 60. So the acceleration is 9 point, well, let me write it in a more exact form first. We know the sine of 60 is root 3 over 2. Okay, if you find the sine of 60 degrees, if you're in degree mode here, which we are, we find the sine of 60, you'll realize it's root 3 over 2. Okay, so this is going to be g times root 3 over 2. So it's g times root 3 over 2, which I'll write down its value as a decimal. So this times 9.8. which gives us 8.487. Okay, 8.487. Okay, 8.487 ... which is 8.49 meters per second squared. So that's the acceleration of this as it's going down the plane. Okay, now for part B. It says show that the time taken for P to reach the hole is 0.904 seconds, correct to 3 significant figures. So what we're going to do here, we know that it's accelerating down the plane, and the acceleration is given by, in exact form, g root 3 over 2. That's the acceleration going down the plane, right? It's constant acceleration. So we can use the Suvat equations. We can use Suvat. All right, so what we know straight away is the initial velocity is 0. We don't know the final velocity. We know the acceleration is, as we just written, g times root 3 divided by 2. The time is what we have to find. Okay, and we also can work out what this distance that it travels is, because it's going from the top to the bottom to the hole. So we can work out that distance because we have the dimensions of this triangle here. So what we're trying to find is the distance between this point and that point. That's what we're trying to find. That's what S is in this case. That's what S is. So we can say, using this triangle, we can say that if I look at these two, this is opposite, this is adjacent, this is the hypotenuse. So I can say the cosine of 30 degrees is equal to the adjacent 3 over the hypotenuse S. So S equals 3 divided by cosine 30. So it's 3 divided by, now cosine 30 is root 3 divided by 2. So that gives you 6 over root 3. I'm keeping things exact form. Let's just rationalize that. That's 6 over root 3. You multiply it by root 3, both top and bottom. That's 6 root 3 over 3, which is 2 root 3, basically. 6 root 3 over 3, which gives you 2 root 3. So that is S, 2 root 3 meters. Okay, so this is what we have so far. And we have S, U, A, and T. So we have to think of a equation of motion that will help us to work out the value of T. So we need S, U, A, and T. It looks like it's S equals UT plus half AT squared. All right, so we got S, which is 2 root 3. U is 0, so that becomes 0, equals a half times A, which is G times root 3 divided by 2 times T squared. Okay, so the root 3's will cancel. So we're left here with 2 equals G over 4 T squared. So you're going to have 8 over G equals T squared. Therefore, T is equal to the square root of 8 over G. So the time it takes is the square root of 8 over 9.8, which gives us 0.9035. 0.9035. It goes on like that. So if we look, we have to round it to 3 significant figures. So they're going to have T is equal to 0.904 seconds, and that's exactly what we have to find, or we have to show here. Okay, so that's fine. So there's part B done using Suvat. Now for part C, I think we turn our attention now to the particle Q, which is traveling on a rough plane going down the slope here. So this slope now is a rough plane. So let's look at the forces acting between it. So they've told us that this is going on a rough plane, and we got to find the we know the acceleration of this is 3 meters per second squared. We know the acceleration. We've got to find the coefficient of friction between the plane and this particle. So the forces acting on this particle will be including now friction. So you've got its weight acting vertically downwards. You've got the reaction force, which this time is going to be important. It's perpendicular to the plane. So you've got the weight, which I'll call mg again. This is the reaction force. But now we have a third force acting, which is friction, which is opposing its motion down the plane. So this friction has reached its maximum value. F max has been achieved because it's moving. The object is in motion. So the friction has reached its maximum value, and it's acting up the plane as the particle is moving down the plane. Okay, so let me think about now resolving the weight parallel and perpendicular to the plane. So parallel to the plane this way, perpendicular to the plane this way. So now I know this is 60. Now we're normally given this angle here. So I know that this is 60, this is 90, this must be 30. So I'm going to use this angle here to keep it common or keep it, familiar to you. But we could, if we want, take this angle as 60. And then this would be mg cosine 60 and mg sine 60. All right, but I'm taking this as 30, which means that this must be 30 degrees. Okay, if that's 60, this must be 30. That's one way you can do it like that. All right, or we can use similarity as I explained in a previous video. Anyway, this component of this weight is going to be mg times going into the angle cosine 30. So this is mg times cosine 30, and this is the component of the weight in this direction. You have to go away from the angle, so it's mg sine 30. So now we have F max equals mu r. All right, so we want to find what mu is. Now, if we think about it, mu is equal to F max over r. Okay, F max over r. All right, so if I resolve the forces parallel to the plane, now it's moving down the plane, so I'll resolve in this direction. So I have mg sine 30 minus F max is equal to the mass times acceleration. Again, we don't know what the mass is, so we're just going to call it m times the acceleration, which is 3. That's using F equals ma. The resultant force equals mass times acceleration. So sine 30 is a half, so this gives you mg divided by 2 minus F max is equal to 3m. So therefore we can say F max is equal to 3 mg over 2 minus 3. So you have mg over 2 minus 3m. That's F max. If I simplify that a little bit, that's going to give me, if I make that into one fraction, that's going to be 2. There'll be mg minus 6m over 2. Okay, that's F max. All right, and to find what r is, we can resolve perpendicular to the plane, in which case we'll have r is equal to, if you resolve this as we see here, perpendicular, you've got mg cosine 30. Here there's no resultant, there's no acceleration in this direction, so the force up and the force perpendicular to the plane up and down are both equal to each other. So we know cosine of 30 is going to give us root 3 over 2. So r equals root 3 over 2 times mg. All right, that's what r is. So we've got to find the value of mu. So mu is equal to mg minus 6m over 2 divided by root 3 mg over 2. Okay, you're dividing those two. Okay, you're dividing them. Now, what we can see here is you will end up with mu equals, I'll take this m out as common, g minus 6 over 2 times 2 over root 3 times mg. Okay, because when you're dividing two fractions, you write the reciprocal of the second one and multiply them. The 2's cancel, the m's cancel, so we're left with mu is equal to g minus 6, okay, over root 3 times g. So you can say over g root 3, which gives us, now remember g is 9.8, so I'm going to have 9.8 minus 6 over 9.8 times the square root of 3. And that gives us 0.22387. 0.22387, which is to 3SF 0.224. So we know mu is equal to 0.224, correct to 3 significant figures. And we had to basically write it to 3SF. So there's the answer to part C. Okay, and now we got to go on to part D. It says, in order for the two balls to arrive at the hole at the same time, Q must be released t seconds before P. All right, so P, okay, it took P, okay, so the time for P to reach the hole, so for the time for P to reach the hole is given in the last part of the question as 0.9035. I'll write it in the more exact form. 0.9035. 0.9035 seconds. All right. And we want to find the time it takes for Q to reach the hole. And then we can see that the difference between those two times will be the time that you must release Q so that they arrive at the same time. Okay, because you want to release Q at the time before. If Q takes long, let's work out how long it takes Q. So we got to work out the time it takes Q. Time it takes Q. Let's work that out first to reach the hole. So that's what we're working out now. All right, so very similar kind of situation. We know the acceleration is already given. So we know the acceleration is 3 meters per second squared. We know it has to travel this distance, and this distance here that it's traveling can be found using trigonometry. Again, same kind of situation. This is the adjacent, this is the hypotenuse. So in this case, you've got, again, cosine, this time cosine 60 is equal to the adjacent over the hypotenuse, which is, it's going to be 6. But it's S, I know it's going to be 6 because this is a half, isn't it? So cosine 60 is a half. So you have a half equals 3 over S. Okay, so if you cross multiply, S is going to be 2 times 3, which is 6 meters. So this is 6 meters. So we know that using SUVAT, it's traveling 6 meters from there to when it reaches the hole. It starts off with at rest 0 meters per second. We don't know what the velocity is by the time it reaches the hole. We know it's accelerating at 3 meters per second squared, and we're taking this as positive because it's going down, and the time is what we have to find. Let me call the time here T, capital T. Okay, well, let me call it the T of P, because this T that we've been given here is a different. This T is the time at which Q must be released. So that's what our T should be. So I'll call this TP. So we know that. No, sorry, TQ. TQ. Okay, TQ, not TP. We've got TP already. So this is time Q. So this is TP equals 0.9035 seconds. And we're going to find what TQ is. Again, the same equation. S equals UT plus a half AT squared. That will work because we have S, U, A. We've got to find T. All right, so we got 6 is equal to 0 plus a half times acceleration, which is 3 times TQ squared. TQ squared. Okay, so that is the. One second, let me just plug in my. Yeah, that's better. Okay, so now this is going to give us 12 over 3, which is 4. So you got 4 equals. 1 second. So you have 4 equals T squared. Therefore, T is equal to 2 seconds. So that's TQ, sorry. Okay, so we know it takes for P to reach the hole is 0.9025 seconds, and for Q to reach the hole is going to be 2 seconds. We don't take the negative value because time can't be negative. So those are the times it takes for those two to reach the hole. Now, when should Q be released? Okay, when should Q be released? Well, it should be released so that they reach the hole at the same time. So that's going to be the difference between these two. Okay, so it should release 2 minus 0.9025 seconds before P is released. Okay, then they will reach the hole at the same time, so that they'll get exactly the same time. So you're going to have 2 minus. So you have 2 minus 0.9025, which gives us 1.0975, 1.0975 seconds, which is going to round to 3SF, 2 decimal places. 2 decimal places, that's going to give you 1.0. It's going to be basically 1.10 seconds. So you have to put the 0 there to show that we rounded to 2 decimal places. What's going to happen, this 7 is going to make that become 10. You can't write 10 here. It'll be 1.10. Okay, so time is 1.10 seconds. That's the answer for part D, and that concludes this question. Okay, so I hope that was clear. Other questions from this particular Solomon L mechanics paper M1 can be found in the playlist that should appear in this area. Other questions from this end of topic worksheet, forces and friction, can be found in the playlist over here. Other questions from forces and friction in general from M1 in this playlist, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.